Hello guys, welcome to the channel. I hope you all guys are fine and doing great. Today we are going to discuss this possible path in a tree problem of GFG. So let's move on to the problem guys. So here what we are given a weighted tree with n nodes and n minus 1 edges, okay? And we are given q queries as well. And like basically what we are given, okay, we are given a tree with n nodes, okay? Like this is a tree with n nodes. So n nodes mean n minus 1 edges and minus 1 edges. Now we are given a query array that will contain q queries like q1, q2 like this up to q, okay, number of queries. Now for each query, I need to find out number of path in my tree that I can move across using weight less than equal to x of an edge. Suppose this q1 value is x. So what basically it means, if my q1 value is x, q1 value is x, then I need to find the count of path, this path, count of these path, so that the weight, like suppose it's a, it's b, the weight traverse between two nodes are less than or equal to x. Okay, means when I'm traversing and a path, when I'm going from path a to path b, means node a to node b, the maximum weight should be less than equal to x of an edge. Okay, maximum weight of an edge should be less than equal to x. So what does it basically means? So if I gonna make it simple, so for q1 I need to build a tree, I need to build a tree again that will contain all the nodes, all the edges whose weight is less than is equal to, suppose it's q1, okay, less than q1, suppose q1 is, okay, q1 is q1. Now for query 2, I need to build a tree that contain only edges uh, which have weight less than equal to q2. Like for example, suppose this is my tree, suppose for example weight 1 4 9 2, okay, node, okay, this is my tree. Now my q is 3, q is 3, then my tree will be like this, of one path. I cannot take this edge, I cannot take this, can this, I cannot take this, I will take this. Okay, so how many paths I will have? I will have two paths, one path, two paths. I will have only two paths. But if my this is 4, then how many paths I can take this one, because its value is 4. I can take this one. So how many paths I will have? I have total 4 nodes. So 4 nodes mean 4 into 3. From one node, like how many total paths I will gonna have? It's a possibility of choosing node 1 into possibility of choosing node 2. So how many possibility of node 1 I have? 4. How many possibility of node 2 I have? 3. So total 12 path. So total 12 path I will gonna have. Wait. Oh, sorry, 6. Okay, it will contain two path, like for this one path, this one path. Okay, like basically ignore this set. I have 4 nodes. I have to choose an 2 nodes. So how many ways? 4 factorial upon 2 factorial upon 2 factorial. Basically I can say this is 4 into 3, 2 factorial we're gonna cut down, 4 into 3 12 divided by 2 6, so 6, so total 6 path. Like this is total number of pairs in which I can choose 2 nodes exactly. Okay, total number of ways of choosing 2 nodes from 4 nodes is this. 4 is 2, it is 6. Okay, so I can choose 6 if my value of edge is 6. I can take weight less than equal to 4. Okay, similarly, so now for each query I cannot build a tree, for each query I cannot build a tree. So what I need to do, see, what if I sort all my edges into increasing order of weight, increasing order of weight, so that my for my vector e I know weight of weight of ei2, ei2 is either less than or equal to e I plus 1, I plus 1 2, means weight of this edge is less than equal to next edge. Okay, now I know my all the edges are in sorted order. Now if I make a different array for queries, Okay, from array I will gonna change it into array of pairs. Like suppose my query value are this 4 3 5 1. I will gonna make a new vector array, pair array. It will contain 4 0 3 1 3 1 5 2. 5 is the value, 2 is the index, for which I need to find out 1 3, and I will gonna sort them now. So I will go to new array 1 3 3 1 4 0 5 2. Okay, now see, if I once build a tree for this 1 3, for this 1 3 means 1 3 basically means if I build a tree that contain all edges that have weight less than is equal to 1, then all these edges I can use in this particular for this particular query as well, because I know the weight of my I query is less than equal to next query because I sort them. So I know I don't need to build again and again. So once I know answer for this, using this I can calculate answer for this. Okay, okay, this is the simple way to solve this. Now how exactly I will gonna do this is this is like using a data structure called DSU. Okay, or it is also called union find. Okay, if you don't know about this, then you can comment. I will gonna make a new video on it, but you need to comment for this. Okay, but I hope now you know what is DSU. DSU is nothing but union find. Here what I will gonna do, like suppose I have node this, I have tree like this, I have tree like this, 1 2 4 5, suppose here 6, here 7. Now see, for any query I already have this particular tree. I have this tree built, this tree. Okay, uh, not this, suppose this, and this and this. Okay, I have this. Now suppose in next query, these all suppose weight of this is 1, 3 to 4 is 2, 6 to 7 is 2, and now my query weight is 3. So I need to take all the weight that are less than equal to 3, and now suppose its weight is 3, its weight is 3, and this particular edge weight is 3. So I need to add these two edges. Okay, now for this particular thing I know my answer, this particular I know my answer. Okay, I know how many total number of pair I can have. Okay, this is in my current number of pair is 1 2 and 3, three number of pair I will have. Okay, 1 2 or either 2 1, both are same. 3 4 4 3 6 7 7 6. Okay, 3 4 4 3 are same, 6 7 7 6 are same. Now if I will go to this particular edge, and okay, I will gonna add this particular edge now, 1 and 3. If I will gonna add this particular edge, okay, now I need to add 1 and 3. Now what happens for this particular connected component? Okay, this is TSU. Like here I can find connected component. So all the component connected to this particular, this is connected component 1, this is connected component 2. So all the connected component of my C1 can go to all the connected component of C2. Basically all the nodes of my C1 can now go to C2. So suppose I have X number of nodes here, I can have Y number of nodes. I have Y number of nodes here. So for each of the X node, how many choice I have? Y choice. Like for each particular X node, I have Y is equal to 2 here. So I can make two path from 1 3 to 4, from 2 I can go to 3, go to 4. So how many new number of path I have? It is X into Y, X into Y. So I will gonna add this particular quantity into my answer, that is 2 into 2, that is 4. And I will go, now my new connected component is this. Now my new connected component is this whole is a component. Now this is separate. Now when I am gonna to add this, I need to make this. So how many number of nodes I have in this particular connected component? 2. How many nodes now I have in this particular component? 4. 4. 4 nodes, 1 2 3 4. So how many total number of path I will gonna add by adding this 1 to 6 edges? 4 into 2, that is 8. So how many total number of new path I will gonna have? 8, 4 12 and 3 15. Now suppose this node have value greater than 3. Okay, I have to exclude this now. So I can say 15 will be my answer. Like suppose if this is 3 comma 1, this is this 3. Like suppose my query array is like this. Query array is this, like this. Like query array initially given is like this: 9 5 4 1 3 2. So if I will give indexing, this will become 9 comma 0, 5 comma 1, 4 comma 2, 1 comma 3, 3 comma 4, 2 comma 5. So I know my answer for this particular part will be 15. So means answer of my fourth index of my query array is 15. So the answer vector that I am making, I will gonna put this 15 at fourth index, 0 1 2 3 1 2 3 4. This is my fourth index. I will gonna insert 15 here. Okay, this is how I need to solve this. Now guys, one more thing, this is a whole connected component. Okay, this is not a case, I don't see it before. Okay, but for safe side, what I did, like suppose if I have given a edge like this, which is not possible here, but I just take into consideration, I don't know why. If I have this, then I know 7 and 4 belongs to same component. After adding 1 and 6, this is whole same component. So if 7 and 4 are belonging to same component, then I don't need to add anything, because they already connected. Okay, they already know how many path I will have. Okay, if they are belong to same component, this is simple thing I need to do. Now let's see the code. Okay, this is for DSU. This is my initialization. This is my parent find array to find the final component of my array, final parent of my component. Okay, this is all about DSU, and this is merging. I am merging, like merging these two, merging these two. Okay, like this. If you have any doubt in DSU, you can just comment out. I will gonna make a new video for DSU. Okay, explaining all the things. Now see here, I am sorting this edge array. I'm not making any tree. I am just sorting edge array, because I will gonna make tree in each iteration of my queries array. Then what condition I am using, this is a sorting, this is a manual sorting. Like this is sorting using comparator. Okay, using a compare function. So I'm making a function for two values I and j of my e array. If the second value, like the weight of my I is less than, then it will come before. Okay, basically what does it mean? If this return is returning 1, means it is returning value true, then my I will come before and j will come after. Okay, this is normal sorting. If you don't know about this, please google this. Okay, this is normal sorting using compare function. Now I am making a new array query, and what I am inserting, query is a value of my query and the index of that particular query. Okay, then I am sorting this index will not gonna matter, and after sorting, my value of queries will be in increasing order. I am initializing a DSU n plus 1, because indexing is n-based indexing. If I have 7 nodes, then nodes value will be 1 to 7, not from 0 to 6. Okay, then I is equal to 0, means currently I am at my first index of my h. Current is equal to 0, means current will store the number of current path I have. This is the answer vector of size qr is number of queries I have. Then for each query, then for each entity of my query, if I have some edges remain and the weight of this particular edge is less than the weight of query, like weight of current query, then what I will gonna do, if they don't belong, if current edge does not belong to same component, what I will gonna do, I need to add this particular thing. This will gives me the number of component, the number of nodes in a particular component. Okay, either I can do this, or either I can do this. Like how I can guarantee that the d dot parent will gives me only thing, because I know after calling find function, my node will be directly joined to my parent. Okay, and this is simply I am finding the parent of this, and d dot rank array will contain the number of nodes in a particular component. So number of nodes in first node component, number of nodes in second node component. Okay, component 1 size into component 2 size, I am adding this in my current. If you have any doubt in this, it means you have weak DSU. Okay, you don't have that much great knowledge of DSU. Okay, please read about it. You will gonna understand how this is gonna working. Then I am merging both component. Like now these two nodes component will belong to same component because I merge them. I got a edge that can connect them. I am merging, and after this I am increasing my I. Now check for next edge. Then at last, after doing this while loop, either I have out of the edges, or either my weight is greater than the query weight. So what I need to do, query dot second means the index of that particular query will contain this current number of path. At last I will return answer. This is simple approach. Okay, so you can see all the test cases pass out. Time taken is just 0.15, and this is q into n approach. Okay, n into q. And why this is working? Because this is less than 1.8. Okay, this is n into q approach. Very simple. D dot find and this D dot merge are just of alpha, like of constant function. They will not gonna take that much time. Okay, so I hope you will understand the problem. If you haven't, you can just comment out. I will try my best to explain you. Please subscribe the channel and like the video. Okay, and you can check out my channel for more these type of videos. Thank you for watching this, guys. Stay tuned.